Thank you all very much for joining us on this webinar. My name is Vikram. I work for GL Communications. I am our sales director. I am also joined on this call by two of our senior engineers, Prasad Maya and Swati Ural. They have designed and built this PacketExpert 100G product that we will talk about here today. So recognize many of you on this web conference. However, if you are not familiar with GL Communications, we are a telecommunications consulting company. We are located in Gaithersburg, Maryland, and we also have a development office in Bangalore, India. I am working out of our Gaithersburg, Maryland, USA office. Prasad, Swati, and Sanjeev are joining me from Bangalore. So no matter where you are in this world, we've got you covered in multiple time zones. Anytime you want to reach out to us, please feel free. We were founded in 1986. We've been around for over 35 years. We are a telecommunications consulting company. We provide consulting services, and we also manufacture test and measurement equipment. Our test and measurement equipment cover all sorts of different telecommunications networks, including Ethernet networks, wireless networks, 3G, 4G, 5G, VoIP, fiber optic networks, legacy networks such as T1, E1, and even the old analog public switch telephone network. We have test equipment for all of these different types of networks. Our test and measurement equipment can do a lot. It can analyze existing traffic over these networks. It can emulate traffic flows over these networks. We can do conformance testing to different protocols. We can do surveillance and so forth. We can visualize all the traffic. We can capture the traffic, store it long term. We have portable solutions. We have rack mount solutions. Our solutions, as you will know, as some of you know, are very cost effective. So please contact us for whatever your test and measurement needs are. I am confident that we have a solution for you. Today's webinar is about Ethernet and IP testing. The majority of the backbone networks throughout the world are now running Ethernet. It has become the dominant layer 2 technology, even for wireless networks. As soon as it gets converted to wired networks and going through the core network, that core network is running Ethernet and also running IP over the Ethernet. So all of the core networks are running Ethernet basically, and the networks that are not running Ethernet are migrating over to Ethernet. So we see that here in the United States, a lot of the government agencies which have communications networks, which were legacy networks, are slowly but surely transitioning to Ethernet. So when we talk about Ethernet and IP infrastructure, what are we talking about specifically? What are we testing? What needs to be tested? So it can be everything from cables and switches and routers, gateway devices. When I say gateway, I mean devices that can convert one type of legacy technology, such as analog or T1 or E1, to Ethernet. You may be testing all sorts of different types of networks, virtual local area networks, virtual private networks. You may be testing some specific client to server connection, some client-to-client connection, some end-to-end network path from customer premises to server rooms, server data centers to other data centers, all sorts of different types of network paths that you may be interested in testing. So customers who come to us, they are either interested in testing an individual device, some custom built switch or cable or something like that, all the way to some end-to-end network path. So our test equipment can cover all of these different types of scenarios. In terms of when to test, what frequency to test, again, each customer is different. Sometimes customers just need a one-time test. Some customers need to test after or before an infrastructure change or a circuit handover. There's factory acceptance testing, benchmark testing, many different types of testing scenarios, and they all require different types of testing frequencies. And similarly, how to test. So maybe you are just interested in fundamental statistics, layer 1 or layer 2 statistics like bit errors. Maybe you want to go beyond that. Maybe you want to look at packet loss, throughput, round trip delay or one-way delay, and so forth. So every customer is different. We find that each customer is interested in different characteristics of their network or device. No matter what the testing scenario is, you probably want to test at different types of speeds, different packet sizes, different types, different protocols. Perhaps you're just interested in raw Ethernet frames across the network. Maybe you're interested in IP, maybe you're interested in MPLS, maybe you're interested in UDP traffic, TCP, and higher up the network stack. Different protocol headers, different protocol payloads. And so you really want to get a very large variety of different types of traffic going across the network, because you will be surprised that the network may behave perfectly for one type of traffic, but may not handle another type of traffic very well at all. So these are just things to think about when you think about testing a network. Here's some more examples. Oftentimes service providers come to us. They are responsible for providing service level agreements to their customers. Things like guaranteed information rates and excess information rates and things like that. So they are committed to providing a certain minimum throughput and bandwidth to their customers. So they come to us to test their own networks to make sure it is matching their SLAs. The customer that's purchasing that service from the service provider will also be interested in our equipment to make sure that the SLA is being met. They want to independently verify that SLAs are being adhered to. This is a common case amongst government agencies. They want to independently determine whether the service provider is providing the service that they are expecting. Equipment manufacturers buy our solutions to test during the development phase, or do some sort of long-term regression testing, or some production testing. We have all sorts of specialized testing scenarios. Some customers need to know the precise delay going across a network or a device down to the microsecond level. So they need precise microsecond on certain events going across their network. And again, in the lab, a lot of our equipment is used in isolated lab scenarios as traffic generators, network emulators, and so forth. So here are some more real-world examples. So when you are testing, you want a test device that's very flexible, right? You want something that can cover many different Ethernet standards, many different data rates, optical signals, electrical signals, single mode optical, multi-mode optical, electrical over RJ45, and so forth. You want different types of rates, 1 gig all the way up to 100 gig and beyond. So flexibility is key. You want to be able to cover many different types of tests: bit error rate testing, RFC 2544 testing, Y.1564 testing, loopback testing, and other different types of tests. You want the test device to be able to meet all of these different types of standards without having to purchase different licensing or get different test devices and so forth. You want one all-inclusive solution. More and more, we find that customers need scripting capability: Python, Java, C++, C#. This is especially useful when you have to run thousands of tests over and over again. You don't want to click buttons over and over again thousands of times. So you want to be able to write a script, and the script should be able to do everything that a GUI can do. And through a simple for loop or while loop or whatever it may be, you want to be able to just run through thousands of different testing scenarios over extended periods of time with just one click of a button, and that's something to look at. Or you may just want to use a graphical user interface. Maybe you just want to do a test every now and then, and the graphical user interface is good enough. And finally, of course, cost is always an important factor. So with this in mind, we have designed the PacketExpert 100G. This is the latest evolution in our PacketExpert series of products. PacketExpert 100G has become our best-selling product, actually, as customers are now pushing to much higher and higher speeds, 40, 50, and 100 gigabits per second. With the PacketExpert 100G, we can provide different network interface cards, different port densities. On the left-hand side here, you see a portable solution with 2 Ethernet ports. On the right-hand side, you see a solution with 8 Ethernet ports, and they're all configurable from 1 gig up to 100 gig. This is on the top row, you see our portable solution, and on the bottom row, you see our rack mount solutions. No matter if it's the portable or the rack mount solution, the software is the same, the functionality is the same. You can do everything you can in both form factors. It's just the form factor that changes. So here on the bottom you see a rack mount solution with again 2 ports, and then again we can go up to 8 ports. These are custom built PCs. We have customized the cooling, the RAM, the storage. They're all running our proprietary PacketExpert software. We've optimized the disk write speeds. It is a custom built solution, and each customer will have different requirements. Maybe they want to store the traffic, so they may need different requirements on storage and RAM, and we can customize all of that. So these are very flexible solutions, and this is what it looks like. I should also mention the portable solutions. We include a very convenient Pelican case with a custom cutout, styrofoam cutout. It's very easy to just put this in a Pelican case, roll it around, and take it with you into the field, pack it up again, and move it from place to place. We also provide all the SFPs and cables and keep it all organized and labeled for you, so there's no confusion in terms of any of that. Customers always ask us, are you compatible with this SFP, that SFP, SFP pluses, QSFPs, QSFP pluses, QSFP 28, single mode, multi-mode, breakout cables. Basically, the answer is yes to everything. Without getting too into the weeds here, we are compatible with all these different types of SFP transceivers. We've never had an issue, but we always like to supply the SFPs, QSFPs, and so forth when we provide a solution to you. So please let us know what type of interfaces you need, and we will supply the cables and the SFPs for you. That way you have one consistent solution. You don't need to go to multiple vendors and buy multiple different things from multiple different places and keep track of everything. We like to provide the complete solution. So we'd be happy to have a conversation for your specific accessories, what accessories you need. But the answer is yes, we are compatible with all of these different types of transceivers. Here again, I think here we're showing a lower data rate, 1, 10, or 25 gig SFP, but again, same concept. Let's talk about how you deploy this. So if you are testing an entire network path, then you would want 2 PacketExpert devices, one at each endpoint, right? If you're trying to test an entire network path, then you would want to deploy a PacketExpert at the endpoints. Now, you can either be at one of these PacketExperts controlling it directly, or you could be at some centralized location. The PacketExperts will be on a management network, and you can actually control them through a web browser. So they will be connected to a web server through a management network, and then multiple users can log into that web server through a standard web browser. And so our user interface for the PacketExpert 100G is a web-based interface. If you're familiar with our lower end PacketExpert models, those are not web-based. So we've decided to make a web-based interface because it's much easier in terms of multi-user capability. This was a customer request, and now we have incorporated it. So it is a pure web-based interface, multi-user is supported, and from one web-based interface, you can control all of the PacketExperts deployed on the network. You can control another PacketExpert to be a loopback device. So meaning one PacketExpert will send traffic over the network, the other PacketExpert will loop it back, and then the PacketExpert will make the measurements, the round-trip measurements, round-trip delay, packet loss, things like that. Here again, it's basically the same. Here I'm depicting 2 data centers. We have a lot of customers that deploy PacketExpert 100G into the data center. So we'll start with bit error rate testing. It's the most basic type of testing. Bit error rate testing is very simple. I think many of you are familiar with it, but if you're not, the idea is that one PacketExpert sends a predefined bit stream across the network to another PacketExpert. That bit stream is some pseudo-random sequence. When it arrives at the far end, that packet expert knows what the bit stream is, what the expected bit stream is, and compares it to what it receives over the network, and then can simply make the measurements. Oh, okay, this is a 1, but it was supposed to be a 0. This was a 0, it was supposed to be a 1. This is how many bit errors I'm getting. The test is bidirectional, so you can do tests in both directions independently. Completely different bit streams, completely different data rates, completely different protocols, packet sizes, whatever. You can do it at just the Ethernet layer, but if you're going over an IP network, you would incorporate IP packets. So that's bit error rate testing. We support all the standard bit error rate patterns. You can also define your own bit error rate pattern. Raw Ethernet, we can do VLAN, we can do MPLS, IPv4, IPv6, and UDP. So we can put the bit pattern in the payload of whatever layer you wish to go. We can intentionally introduce errors so that you can see what the errors would look like and whether the errors get detected on the far end. The traffic is fully customizable. You have full control over the protocol headers, traffic sizes, and so forth. You could run multiple BERT tests simultaneously because you can control multiple devices simultaneously. Each device, like I mentioned, has up to 8 ports. So you can run 8, so all 8 ports could be running their own independent bit error rate test. And finally, we have a very nice real-time graphical display of all the data. I won't go too deep into the screenshots, but I just want to mention that for all these are all web-based screenshots. At any place you can just click on a field and edit it directly. So source MAC address, destination MAC address. You see all of these different protocol headers. You have full control over them. So things like MPLS labels, you can set the labels to be whatever you want, and so forth. So I'll kind of fly through some screenshots just so you can get a flavor of what it all looks like. Here you see a test that's running, total number of frames received, link status, number of bit errors, number of out of sequence packets, out of error free seconds, all of these different types of simple fundamental parameters. You see it in a very easy to digest web-based interface. You get the full, once you stop the test, you can, while the test is running, you can see more details in real time. Is there pattern synchronization? Is it out of sequence? Is the link up? All this type of stuff. You get a whole bunch of other statistics. Again, I'll just fly through all this stuff, but we give you statistics on all the frames received, the frame sizes, what type of frames they were. Were they just UDP frames? Were they IP frames? IP packets, UDP packets, checksum errors, and so forth. You get real-time graphs of the throughput and bit errors and so forth. You can also insert bit errors, and you can see them pop up on the graph. You can insert bit errors at whatever frequency you want to insert. So 10 to the minus 4 would be like 1 out of every 10,000 bits you are going to flip the bit intentionally. So that's how you can do bit error insertion. Let's move on. RFC 2544. Again, I think a lot of you are familiar with this test, but if you're not, RFC 2544 goes beyond basic bit error rate testing. It looks at the packet level. So rather than looking at the payload of the packet, it looks at the packet as a whole. I send 1,000 packets. Did I get 1,000 packets back? Did I lose any packets? Did the packets get corrupted? Did I receive the packets in the same sequence that I sent the packets? Did I receive the packets at the same rate as which I sent the packets? So it is more concerned at the packet level. It's used to benchmark devices like switches and other layer 2, layer 3 type devices. It's usually used for individual devices. You could use it over an end-to-end network path as well, but typically just for isolated devices. So here's a perfect example. So on my screen here, if you're testing a switch, you could just hook up the PacketExpert directly into the switch and then just blast traffic through the switch and test whether the switch is keeping up. Is it passing all the traffic through without introducing errors? Is it losing packets? Is it corrupting the packets? And so forth. So you can get the full performance. You can really stress test the switch using the RFC 2544 methodology. Now, if you're going over a network path, then maybe what you want to do is you want to place two packet experts at either end, and one packet expert generates the traffic, goes through your network. On the other end, that packet expert acts like a loopback. So it just takes the packet, the source and destination MAC address, IP address, UDP ports, and so forth. If you're going over an actual network, that loopback device needs to do that address swap before sending it back over the network. But as long as it does that, yes, you can use your own loopback device. But then again, the packet expert can act as a loopback device at wire speed without dropping any packets at all. Okay. So full flexibility in the RFC 2544 test. You could go up to the UDP layer, or you can just stay at Ethernet or anything in between. Throughput, latency, frame loss, back-to-back, one direction, bidirectional, it's all doable. You can set the trial duration, set the frame size, number of trials, all full customization is possible. Just like before, it's a very simple user interface, web-based interface. You can set all the parameters and so forth. Let me skip ahead here in the interest of time, and okay, yeah. So here, what I'm showing again, this is with the rack mount solution. It's the same concept. You go through your device or network under test and back to the packet expert, and then you simply do all the measurements. And again, if you're going through a full network path where the two ends are in remote locations, you would have a packet expert at either end. So this is basically the same depiction as before. I'm just showing the rack mount form factor. Okay, the graphs, just like before, you have very easy to view graphs of the throughput. When I say east to west, west to east, that just means both directions, going from one packet expert to the other, and from the other to the near end packet expert. In both directions, simultaneously, you will see all of the results. You will sometimes find that one direction behaves differently than another direction. So when that happens, that's typically some misconfiguration of your device under test, and it's always good to test in both directions simultaneously. With the latency measurement, we have microsecond precision on the latency measurement. So customers always ask about that. We have microsecond precision on the latency measurement. There's a drop-down menu here where you can plot all the results in either milliseconds, seconds, or microseconds. So you can get that level of precision on the latency measurements. Again, in both directions simultaneously. The next type of test you want to consider, which is Y.1564 testing. Bit error rate testing in RFC 2544 have a major limitation, and that limitation is that you can only send one stream. One port is sending one stream of traffic through your device or through your network, and then you're doing the measurements on that one stream. Well, the Y.1564 methodology is designed to overcome that limitation. In the Y.1564 methodology, you can send multiple streams of traffic simultaneously. They refer to these streams as different services. So they call it like a multi-service test. The basic idea is that each stream of traffic or each service is customizable. It can have completely different quality of service tags, completely different protocols, completely different protocol headers, and so forth. So for all these different streams of traffic, you can see how the network is handling those traffic types. So it goes beyond RFC 2544 and bit error rate testing in that respect. And it's also the best type of testing methodology when you're trying to verify service level agreements over a wide area network. For wide area network testing, I actually recommend this Y.1564 testing methodology because it is designed specifically for wide area network testing. So here you would again have a packet expert deployed at each end of the network. The packet expert at the far end will be a loopback device, and the packet expert at the near end will now send out multiple streams of traffic. So you see each red dashed line is like a different stream of traffic with different quality of service tags or whatever, and it's going over the network. It all gets looped back, and then the packet expert makes the measurement for each stream of traffic independently. Now, you don't have to do it in a loopback mode. you could just have the two packet experts running their own independent tests, one direction or one-way testing. So this packet expert just sends a traffic stream to this packet expert, and meanwhile that packet expert sends its own stream of traffic to the near end packet expert, and that packet expert does the measurement. So you can do it that way as well. Whiteout 1564 testing, again, it's used to measure, to validate service level agreements. It looks at things like committed information rate, excess information rate, which is like a best effort traffic. It'll analyze different traffic policing policies and other key performance indicators. So usually in these service level agreements, the service provider will provide metrics for committed information rate, excess information rate, and traffic policing as well. So this methodology is designed to verify those types of rates. There's different types of color. You can tag the traffic with different colors. These are basically different types of prioritizations. So UDP traffic can be prioritized differently than TCP traffic, and so forth. So this is all baked into the SLA, but then also sometimes the customers can just set these parameters on their own in their own infrastructure. They can literally go into the routers and set these parameters. Yeah, so it goes on and on. You have type of service, DSCP tags, and things like that. The way the test works is that you first do each service on its own, one service after another, and make the measurements for each service, and then you measure what happens with each service. So voice, video, and data traffic all simultaneously going over your network, and you get the measurements on each traffic flow. Here again are more screenshots on all of this. When you test, you can step up the throughput. At this throughput, I'm seeing that not all the traffic goes through. So now you can really systematically test that committed information rate parameter. Okay, in one nice web-based interface, just like before, you see all of the data for all the different step sizes for all the different services. In a simple drop-down menu, you can select each service and so forth. We also already mentioned that, again, there's a web server that is controlling all of the packet experts. You browse to that web server and you get all the information. You can also secure that web server with the username and password and you can make this an HTTPS connection as well. And so you can have a secure connection to the web server. Again, from one user can control multiple packet expert devices. Multiple users can log into the same packet expert device. When you look at the screenshot, so when you open up the web-based interface, you simply click a drop-down menu to pick whatever application you're interested in. You can reserve one of the devices so that no other user comes in and starts messing things up while you're running a test. So you can reserve the device for your own testing and so on. A couple other interesting features, we can do things like we can look at the clock frequency for any given port. We can look at the frequency, basically the fundamental frequency of the data being transmitted over the wire at layer 1. You can measure that clock frequency. You can also, when it's transmitting, you can intentionally deviate from that frequency to see how it behaves on the other end. How your device or whatever behaves when the clock frequency changes or there's an error in the clock frequency. Okay, you can export all of the results into a PDF or a CSV file after the test is done. Very easy to export the report. You also have event logs in real time. You can save these at any time as a CSV. And you can get all sorts of different that take place during the test. I want to conclude by talking about the automation that I mentioned at the very beginning of this slide deck. We support Python scripting with the PacketExpert 100G. The way the Python scripting works is that the PacketExpert will be running a background server, and that server will be listening to commands over the network. And you will then be running a Python on some client PC, or you can run the Python shell on the PacketExpert itself, that's fine too. And that Python shell will connect to that background server, and then you can execute all of the commands in the Python script. So that's very, very nice. You can run the Python script from the same PacketExpert device or remotely. You can run the Python script from a Windows or a Linux-based PC, no problem there. And we provide a whole API library. We also provide sample scripts to help you get started. And we also, if you have any issues or concerns about your Python scripts, we can also help you. We can take a look at your script and provide feedback and assist you with writing the scripts. But the sample scripts are very easy to use. I show you a screenshot right here. The sample scripts are very easy to modify, very easy to just change parameters like IP addresses, listening ports, and things like that. You can load configuration files and just start and stop the test. You can export data anytime you want. So if you need to export the data while the test is running, a Python script is the way to do it. So while the test is running, at any moment in time, you can export statistics to a text file or a CSV file, and then you can do whatever you want with that data. So the Python scripting gives you full flexibility, full versatility to do any type of testing scenario you wish. If you've looked at other vendors, I think you've probably found that other vendors do not offer this Python scripting capability. It's one of the major advantages of our product, and the support we provide with the Python scripting is also a huge advantage of our solution. The Python scripting works for all of our applications: bit error rate testing, RFC 2544, Y.1564, loopback, all of it. There are sample Python scripts for those applications that you can just load up and fire away. You can use whatever Python shell environment you wish. No issue there as well. So thank you all so much for joining us on this webinar. If you have any questions, please contact us at info@gl.com. If you haven't done so already, please subscribe to our newsletter. We put out weekly newsletters talking about feature updates and new software releases and things like that associated with all of our products. Thank you.